let's define the points in the two-dimensional, three-dimensional coordinate system. So in the two-dimensional coordinate system, we have the x direction and the y direction. And if we would like to draw a point with the coordinates t and 3, for example, we need to go 2 units in the x direction, 3 units on the y direction, and find the point which is going to be on the intersection of this vertical line and this horizontal line. So this point is going to be with the coordinates t and 3. So we can define the curves on the 2D in the same manner, right? So if we're given some equation y is equal to the x squared, and if I would like to draw this, basically I need to find all the points on this curve. I need to find the points which are going to satisfy this curve and just connect them. Okay, so all the points along this curve are going to satisfy this equation, right? For every single point with the coordinates x and y, if we substitute x and y coordinates to this equation, it is going to be substituted. It is also important for us to know how to find a distance in the two-dimensional coordinate system. So if you're given a point in 2D, the 2 points, say one point was the coordinates x1 and y1, and the second one was the coordinates xt and yt. The distance, the shortest distance, I would say, between these 2 points can be found using the Pythagorean theorem. So in order to do this, we need to build a triangle, right? So with the right angle, where we can find the length of this side, this is going to be the difference of the x coordinates of these 2 points. It's going to be xt minus x1, and this side of the triangle is going to be the difference of the heights, right? It's going to be the difference of the y coordinates. It's going to be yt minus y1. And if I know the 2 sides of the right triangle, I can find the third along the side using the formula. It's going to be the distance between these 2 points is equal to the square root of xt minus x1 in the square plus yt minus y1 in the square. So this is how we need to define the distance in 2D. So if we go to the 3D, we're going to use the same analogies. So if I would like to draw a point, again, we need to go in some units in the x direction, some units in the y direction, and some units on the z direction. Then just draw the lines and find an intersection point. And this is going to be the point with the coordinates, for example, 2, 5, and 6, maybe. Right? So in the same manner, we can find the distance between the 2 points if we're given the point with the coordinates x1, y1, and z1, and the second point was the coordinates xt, yt, and zt. The distance between the points p1 and p2, it's going to be the square root of xt minus x1 in the square plus yt minus y1 in the square plus zt minus z1 in the square. So at the same time, we can draw the curves in the 2-dimensional space or in the 3-dimensional space. So one example will show you the difference between the 2 coordinate systems. So let's say I would like to draw a line with the equation x is equal to the 5, right? Basically, this is the line. So in order to do this, I need to find all the points which are going to satisfy this equation, right? So I need to build the line so that the points along this line are going to have always x coordinate to be equal to the 5, and I don't care what is the y coordinates, right? So for example, here, if I choose the x to be equal to the 5, it's going to be the vertical line here. And if we go through along this line, so all of these points are going to have the x coordinate to be equal to the 5, right? For example, this is going to be 5 and 10, maybe 5 and 5. This point is 5 and 0. So if you go through the points here, all the points have the x coordinates to be equal to the 5. So when we explain the equation x is equal to the 5, graphically it looks like just a vertical line. And now in the 3-dimensional space, if I would like to draw y is equal to the 5, right? So this is not just a line anymore, right? So when I draw the 5, it's going to be this. So this might be the points on this line, or this might be points on this line, or this might be points on this line, or on this line, right? Because for all of these points on this plane, all of them have the y coordinates to be equal to the 5, right? So when we explain this equation, we say that no matter what is the x and z coordinates, y coordinates should be equal to the 5. So if we would like to do z is equal to the 0, for example, it means that we just need to draw this xy plane, right? Or basically this is just the ground. Z is equal to the 0. So if we would like to do z is equal to the 5, it's going to be some plane which is some units above the ground. So now let's talk about the difference between the defining of the circles. So we define the equation of the circle using this equation: x minus a in the square plus y minus b in the square is equal to the radius in the square, right? So this is the equation, the general equation of a circle with a center at the a and b and with a radius r. So the concept of the circle of this equation means that along all of the points in 2D, we need to find only those points with the coordinates x and y, so that the distance between this point and the center, which is x minus a in a square plus y minus b in a square from the square root, right, is equal to the radius, right? Is equal to the radius. So because if you find the distance, it's going to be equal to the radius. Basically, we need to choose all of these points along the circle are going to have the distance to the center to be equal to the radius. They are far away from the center in r units. So in the same manner, using the same concept, we can write down the equation of the sphere, right? In the 3D, the equation of the sphere should satisfy the condition so that all the points on the sphere should be far away from the center in a distance of the radius of the sphere, right? So in order to do this, so let's take some point with the coordinates x and y and z. So the distance between x, y, and z and a, b, and c in 3D is going to be x minus a in a square plus y minus b in a square plus z minus c in a square. And this is the distance, right? And this distance should be equal to the r. If you square both of the sides, it's going to be this is equal to the r squared, and this is the equation of a sphere. So let's do an example. So let's say we're given the equation of some curve on 3D. It is x squared plus y squared plus z squared plus 4x minus 6y plus tz plus 6 is equal to the 0. So we need to show that this is a sphere. In order to do this, we would like to write down the terms with x squared and 4x in terms of the complete square, right? We say that x minus some constant in a square is a complete square. So in order to do this, let me write them separately, these two terms and these two terms. So let me start with the x squared plus 4x, right? In order to make a complete circle, we need to add a 4, and since we add a 4 artificially, we need to subtract this, so that the equation doesn't change. Plus y squared minus 6y. So in order to make it again a complete square, we need to add the 9, right? Because it should be written 3 multiplied to the ty, right? So 3 in the square should go here. So since we added this 9, we need to subtract this again. Plus in the end, we need to write z squared plus tz plus 1 minus 1 plus 6 is equal to the 0. So now we can write this as x plus t in a square plus y minus 3 in a square plus z plus 1 in a square, right? And if we add up all these red terms, we're going to have minus 14 plus 6, it's going to be minus 8. If it goes to the right, it's going to be 8, right? So this is the equation of a sphere with the radius square root of 8 and center at the point with the coordinates minus t, 3, and minus 1.